for it to be a bit thicker. Okay, so I'm going to do 30, 60, 90, and we're going to have a bit of a table. Okay, so we're going to have radians, and then we're going to have sine, cos, and tan. So what we're going to do is make sure we know and can refer back to these exact values, right? So we're not wanting to round, we're wanting exact values for what these things equal. So if you're looking at 30 degrees in radians, does anyone remember what that is? It's pi on 6, all right? So pi on 6 is what 30 degrees is in radians. Does anyone remember what 60 degrees is? Pi over 4. And what is 90 degrees? Pi over 3. Sorry, I have put the wrong things in this box. I didn't mean to put those things in there. You are absolutely right. I've actually got the wrong values. I meant to write 45 and 60. I'm sorry. I'm very sorry. I put the wrong values in there. Why is 90 is not very helpful for these things because we already know right angles. We're looking at the 30, 60, and 45 degree triangles. Sorry, I'm not. So these are all the radian values for these equivalent angles, okay? Now let's look at the sine values. If you type in sine 30 to your calculator, you're going to get 0.5. So, but we always want to use fractions, okay? If you type in sine 45 or you calculate it, it's going to be 1 over root 2. These are our exact values, right? Again, this is all based on the unit circle, okay? This is not all triangles. This is based on the unit circle. The sine of 45. It is root 2 over 2. Oh, this is okay, this is true, but this is an unrationalized fraction. Does anyone know what it means to be unrationalized? It means the bottom of the fraction isn't rational, right? Root 2 is an irrational number. If you put this on an exam, it would actually be incomplete. I'm not sure why the book has this. Let me show you why this is root 2 on 2. So 1 over root 2, if I need to rationalize this, if I times anything by 1, it's just the same as itself, right? So I can multiply this by root 2 over root 2, right? Which means 1 times root 2 is root 2. Root 2 times root 2 is 2. We're going to write root 2 over root 2. Root 2 over 2. Yeah. So these are the same thing, but that is an irrational answer, and this is the rational version of that. Correct. We don't want the bottom of our fraction to be irrational. We will do more work on that at another time, but these two are the same thing because I'm multiplying this by 1. Root 2 over root 2 is 1. So I'm not changing the fraction. I'm just rewriting it so that the bottom denominator is rational. All right. Oops. Okay, let's get rid of that. Yeah, we're going to stick with the rational version. Okay, so this one is root 3 on 2. So if we looked at all our answers before and we said all the sides were 1, 2, and root 3, that sort of makes sense. That's why we're getting all these answers here. So the cosine is root 3 on 2. This is the same thing, root 2 over 2. This makes sense, right? Because if this is a 45-45 triangle, you should have two sides that are the same length. And then this is half. And then for the tan one, we have 1 over root 3. For the 45, it's just 1. And this is root 3. Oh, yeah, this is a good thing. It's, yep, should be root 3 over 3, shouldn't it? Yeah, so this is unrationalized as well. All right, let's rationalize. I don't know why the book is giving us non-rational answers, which is very dumb of it. Okay, so this is a table that we're going to keep referring to give us some exact answers as we go along. All right. So I swear the more we practice this, the more it'll make sense. If you think about drawing this, so let's just do one example. Okay, if this is a 45, 45, we said that the side lengths were 1, 1, and √2. So if I want to do sine, so sine of 45 is going to be my opposite over, see what I'm doing? Which rationalized is √2 over √2. Cosine of 45, again, is going to be my adjacent, which is the same thing. And tan of 45 is going to be 1 over 1, which is 1. That's why these work. That's why it's √2 over 2, √2 over 2, 1, right? It's just giving us, instead of having to calculate it every time, it's just giving us a bit of a shortcut for the unit circle only. This is only when we're going by ones. Okay. All right, so what we're going to do is find some exact values. So let's do an example where we're using degrees and radians. Now, it's going to be really important in this topic that you pay attention to whether the question is in radians or degrees, because you will need to change your calculator mode. All right, so let's do cast. Okay, so if I said this is going to be 52 degrees. All right, so I want tan 52. Can you now just try and find me an equivalent angle? Go for it. I will show you what the answer is in a second. Find me an equivalent value. All of it. All right, so you need to pick which quadrant you're allowed to be in. You're allowed to be in this quadrant. We're allowed to be in this quadrant. So where is your equivalent angle? Okay, hopefully you said, well, that's a really bad drawing. That's your equivalent angle. So what am I doing? 180 plus 52, right? So that gives me what am I doing? 232. So my two equivalent angles are 52 and 232. All right, find me another one, please. Find me cosine of 81. Okay, so cosine 81 is like up here. So hopefully you've realized you're allowed to be in these two quadrants. So if this is 81, we should have 360 minus 81, which gives us 279, which means our two angles are 81 and 279. All right, let's do one with radians. Yes. All right, so this time I'm going to ask for, let me not accidentally give you one from the book. Okay, I'm going to ask for pi on 3. Okay, I want an equivalent angle for pi on 3. So first of all, you need to figure out where pi on 3 is. Oh, I need to give you I need to give you more information, don't I? Sine, sorry. Sine pi on 3. All right, hopefully you've realized that pi on 3 is what in degrees? What is it? 60, right? So I told you pi on 3 is 60. So I should be in this quadrant over here because I said that it had to be sine. So that means this is also 60, pi on 3. So then 180 minus 60 is what? 120. So what's 120 in radians? What? Okay, 2 pi over 3. Say it like that. So these are my two equivalent. It's the same thing, but this is the, guys, it is the same thing, but you need to write it like this. Neither of you did it on your test, and I asked you to do it the whole topic, okay? Put the pi on top of your fraction, all right? Maybe you got used to doing it differently last year, but this is the convention of how we always want to write it. It's how the exams do it, so let's stick to that. Okay, so I realize I've just given you a lot of new information. We want to figure out how to read the unit circle, how to read our cast diagram. I've found two really good videos that explain this really well, and I will upload those to Google Classroom if you want to go home and watch them. But for now, let me give you, you don't need to watch it now. But let me give you, yeah, let's see if we can have a go at this. All right, I'm going to stop the recording.